We are asked to find the Riemann sum of the given function over the closed interval from 0 to 3 using midpoints and 6 equally spaced intervals. Let's begin by noting that our n is equal to 6 in the Riemann sum formula, and we proceed with calculating the width of each of the rectangles, namely delta x, whose formula is b minus a divided by n. In our case, b is the right endpoint 3 and a the left endpoint 0, all divided by 6. Upon simplification, we get 1/2. So the width of each of the equally spaced intervals is 0.5. Let's have a look at that. And now we have created 6 intervals of width 1/2. Now we can readily locate the midpoints, and we successively label them as x1 all the ways to x6. It will also help us to list these partition points when we are actually having to perform the calculations. So the very first midpoint between 0 and 0.5 is 0.25. The next one between 0.5 and 1 is 0.75. Now these also need to be a distance of 0.5 apart, so we can now proceed with this pattern and list all 6 of them. And before we go on and find the Riemann sum using these midpoints, let's have a look at the graph. For that, we can again use Desmos and either hand copy or copy and paste as I've done for us. So let us zoom in so that we can see the graph more clearly and can readily identify the boundaries of each of our 6 subintervals, namely 0, 0.5, 1, 1.5, 2, 2.5, and 3. Next, we identify the location of all of our heights at these midpoints. And of course, we understand that in some cases we can't even call this a height, but we know that we're going to get a function value. So it looks like that our first 5 rectangles are drawn from negative heights, and only the last one gives us a positive area. Let us use a different color to complete these rectangles. So here's my very first rectangle, my second one, my third one, and observe as I'm drawing it that I am always guided by my function value, which is giving me the height of the rectangles. And here's my last one. And now let's also indicate that we're noticing that these first 5 are negative, and only the last one is positive. Now here, it does not make any sense to discuss whether we are having an over or underestimate, because it is a little bit unclear how much adjustment we are making here by too much and too little area with these rectangular boxes. But it looks like that our midpoint Riemann sum is actually much closer to the actual value under the graph of this function. We now proceed with calculating this Riemann sum. So M with 6 subintervals is given by the width of each of these rectangles, which is the same, namely delta x, multiplied by each one of these heights. So f at x1 plus f at x2, and so on, all the ways to my last height. And now we use the partition points to substitute. So this is the height located at 0.25 for the very first one. For the second one, the height located at 0.75. All the ways to the last height that is located at 2.75. Let's also show where these heights are located. So here, that height refers to this distance. The second height refers to this length. All the ways to my last height that refers to this length. As we proceed to find the sum, we notice that these x values are going to give me some very messy y values because of my cubic function. So I'm going to use an aid, some kind of calculator. And here's the table of values that I'm now going to use to find the sum, which comes out to be negative 14.0625. And multiplying this value with 0.5 means halving it, and so I get negative 7.03125. This now is the Riemann sum using midpoints and 6 equally spaced intervals of the given function over the closed interval from 0 to 3.